Let us see our next chapter, triangles. In these triangles, what are the different types of the triangles based on the sides and the angles? Now, based on sides, triangles are classified into three types. That is, scalene triangle, isosceles triangle, third one equilateral triangle. Equilateral triangle. Based on angles, triangles are classified into again three types. First one, acute angled triangle. Second one, obtuse angled triangle. Third one, right angled triangle. Triangle is a polygon which consists of three line segments. That is, let us see about these three. Based on sides, that is scalene triangle, ABC. A triangle in which no two sides are equal. That is, all the three sides have three in different measurements. That is, AB not equal to BC not equal to AC. Next, second one, isosceles triangle. That is, a triangle in which any two sides are equal. A triangle in which any two sides are equal is said to be an isosceles triangle. In isosceles triangle, the angles opposite to equal sides are also equal. Now, third one, in this case, we conclude that AB is equal to AC, and from this two, the common part is A. If you remove that one, the rest one are the positions of the angles. Angle B is equal to angle C. Now, let us consider the third one, equilateral triangle. A triangle in which all the three sides are equal and all the three angles are also equal. That is, a triangle in which AB is equal to BC is equal to AC is called an equilateral triangle. And in an equilateral triangle, angle A is equal to angle B is equal to angle C is equal to 180 degrees by 3, that is, each one calculates 60 degrees. Now, let us come to acute angle triangle. Acute angle means which measures between 0 to 90 degrees. And 0 and 90 are not included here. That is, an acute angle triangle. For example, say ABC. A triangle in which all the angles are acute. All the angles are acute. That is 50 degrees, 60 degrees, 70 degrees. 50 plus 60, that is 110, 110 plus 70, 180 degrees. A triangle in which all the three angles are acute is said to be an acute angle triangle. Secondly, a triangle in which obtuse angle triangle. That is, a triangle in which one of the angles is obtuse. One of the angles is obtuse means which between 90 and 180 degrees. That means a triangle in which one of the angles is obtuse. Suppose this is a 110 degrees. Suppose this is 40 degrees. 110 plus 40, 150, the rest one is 30 degrees. Now right angle triangle. Right angle triangle, a triangle in which one of the angles is a right angle. That means in right angle triangle, except right angle, other two angles are acute. Suppose this is 30 degrees. Now this is 60 degrees. That is, in a right angle triangle, except right angle, other two angles are acute angles. Let us see our next concept, similarity of two triangles. Similarity of two triangles. Similarity of two or more triangles, but we are considering here any two triangles. Similarity of two triangles. What is meant by similarity? That is, two triangles are said to be similar. Two triangles are said to be similar. Condition number 1, corresponding angles are equal. Corresponding angles are equal. And condition number 2, corresponding sides are proportional. What is meant by corresponding angles are equal and what is meant by corresponding sides are proportional? Let us see. Consider the triangle, two triangles ABC and PQR. Now let us consider these two triangles are similar. Condition number 1, corresponding angles are equal. Corresponding angles are equal means angle A is equal to angle P. Angle A equal to angle P, comma, angle B is equal to angle Q. Angle B is equal to angle Q. Next, angle C is equal to angle R. Angle C is equal to angle R. That is, two triangles are said to be similar. Condition number 1 is corresponding angles are equal. Number 2, corresponding sides are proportional. What is meant by corresponding sides? Corresponding side of AB, that is AB by corresponding side of AB is PQ is equal to BC by QR equal to AC by PR. That is, the ratio of AB by PQ and the ratio of BC by QR and the ratio of AC by PR must be some constant that is equal, which is called as a proportional. Let us see, one of the important theorem of these triangles is a basic proportionality theorem. Now see, basic proportionality theorem, which is also known as Thales theorem. Now, what is a basic proportionality theorem statement? That is, if a line drawn parallel to one side of a triangle if a line drawn parallel to one side of a triangle, the line divides other two sides in the same ratio. This is a statement. That is, if a line drawn parallel to one side of a triangle, the line divides the other two sides in the same ratio. That is, let us draw the diagram. ABC is a triangle and draw a line parallel to BC. The name is DE. Now, DE is parallel to BC and you have to show that this DE divides the other two sides in the same ratio, that is AD by DB is equal to AE by EC. That is, you have to prove. Given mainly theorem consists of the four parts. Part 1 is the given, part 2 is the RTP required to prove, part 3 is the construction, part 4 is the proof. Now, given in triangle ABC, DE is parallel to BC, that is DE is parallel to BC. In triangle ABC, DE is parallel to BC. Now, RTP required to prove. What we have to prove in this session? The line divides the other two sides in the same ratio. That is, the line is a DE, this divides AB and AC in the same ratio. That is, to prove AD by DB is equal to AE by EC. Construction. Now, let us see construction. Draw DG is perpendicular to AC and EF is perpendicular to AB. Now, proof. Now, and one more thing in the construction, join BE and CD. Join BE and CD. Now, proof. Consider area of triangle ADE by area of triangle BDE. We have to find out the area of this one. Area of triangle we know very well, that is a half into base into height. Now consider ADE. Let us say ADE. ADE. Half into base is the AD into height is EF. That is, from triangle ADE you consider extreme left, that is base, the right angle, the altitude stands on the which that is considered as the base, that is AD is the base and height is EF. Now let us consider triangle BDE. Half into base, that is, let us consider this part BDE, that is BDE, which is an obtuse angle. We know very well, for obtuse angle altitudes will lies outside. For example, that is, therefore the base is BD into height is EF. Therefore area of triangle ADE by area of triangle BDE is equal to half get cancelled because equal parts, EF get cancelled, that is AD by BD. This is equation 1. Now let us see the second part, is the case 1. Similarly consider the second part. Consider area of triangle ADE by, please consider extreme right, that is area of triangle CED, area of triangle CED, that is area of triangle ADE, area of triangle ADE half into, now you consider extreme right, base is AE into height is DG. Now let us consider CED. Let us consider CED. CED again, which is an obtuse angle. For obtuse angle altitudes lies outside, which is a DG, that is half into base EC into height is DG, half into base into height, that is half get cancelled, DG get cancelled, that is area of triangle ADE by area of triangle CED is equal to AE by EC. This is equation 2. See now, but triangle BDE comma triangle CED are on the same base, Now see, these two triangles stands on the same base DE, and between same parallel lines, DE and BC, that is these two triangles BDE and CED are on the same base DE and between the same parallel lines DE and BC, and between the same parallel lines DE and BC. Therefore, what we conclude from class 9th, we know well-known theorem. If two triangles are on the same base and between the same parallel lines, their areas are equal. Therefore, we conclude that area of triangle BDE is equal to area of triangle CED. Both are equal. Since these two triangles lie on the same base DE and between the same parallel lines. Now, from 1 and 2, from 1 and 2, numerators are same, but just now we came to know that denominators is also same. Therefore, we conclude that AD by BD is equal to AE by EC. Hence the theorem. That is RTP to prove AD by DB. AD by DB nothing but BD is equal to AE by EC. Now, after this theorem, we may know one of the important application, that is application. That is, from BPT we know that AD by BD is equal to AE by EC, and add 1 on both sides. AD by BD plus 1 is equal to AE by EC plus 1. Now, LCM AD plus DB by BD is equal to AE plus EC by EC. That is AD plus BD into 1, BD or DB by BD is equal to, similarly LCM is a EC, AE plus EC into 1 EC. That is AD plus DB from the diagram, AD plus DB, that is equal to AB by BD, that is equal to, next AE plus EC, AE plus EC, that is nothing but AC by EC. That is what we understand from this one is total by part. That is the total part is AB and other part AC by EC. Now, application 2. Let us see the application 2. From BPT, from basic proportionality theorem, we know that AD by DB is equal to AE by EC. That is, please make the reciprocal of this one, which becomes BD by AD is equal to CE by AE. Now, after that, adding 1 to left, that is 1 plus BD by AD is equal to 1 plus CE by AE. That is AD plus BD by AD is equal to AE plus CE by AE, that is AD plus BD, AD plus BD, which gives you AB by AD is equal to AE plus CE, AE plus CE, which gives you AC by AE. This is the second application. That is, application 1 is the total by first part BD, this part. Here AB by AD, upper part. That means whether you consider total by part or part by total or part by total, BPT theorem will be true. Let us see the next theorem, basic proportionality theorem. Just we discussed. Now we have to discuss with the converse of basic proportionality theorem. That is, meaning of the converse is without changing the meaning, you have to write from backward. Now statement: if a line divides any two sides of a triangle, if a line divides any two sides of a triangle in the same ratio, then the line is parallel to the third side. Then the line is parallel to the third side. This is the statement of converse basic proportionality theorem. Once recall basic proportionality theorem. If a line divides any two sides of a triangle in the same ratio, then the line is parallel to the third side. Now, what is the statement of basic proportionality theorem? If in a triangle, if a line drawn parallel to one side of a triangle which divides the other two sides in the same ratio. Now let us draw the diagram. ABC given in triangle ABC, the line DE intersect AB at D, comma AC at E, such that AD by DB is equal to AE by EC. That is, next RTP. What you have to show now to prove DE is parallel to BC. We have to prove DE is parallel to BC. Now construction. Draw DF parallel to BC. Draw DF parallel to BC. Now come to proof. Now let us assume that DE is not parallel to BC. Now you have to assume that DE is not parallel to BC. That is, DE is not parallel to BC. Then there exists a point F on AC such that DF parallel to BC. What is our imagination? Let us assume that DE is not parallel to BC. DE is not parallel to BC. But according to the BPT theorem, one line must be parallel to the other side. Then there exists a point F on AC such that DF is parallel to BC. Now that is from BPT, AD by DB is equal to AF by FC. AF by FC from BPT. Now this is equation 1. Now this is equation 2. Now from 1 and 2, AD by DB, that is LHS are equal. Now equate the RHS, that is AE by EC is equal to AF by FC. That is, now AE by EC is equal to AF by FC. Now let us see, AE by EC is equal to AF by FC. Now adding 1 on both sides, AE by EC plus 1 is equal to AF by FC plus 1. That is, AE plus EC by EC is equal to AF plus FC by FC. Now let us see, AE plus EC, go to the diagram, AE plus EC, which will gives you AC by EC, that is equal to AF plus FC, which will gives you again AC by FC. Numerators are same, eliminate on both sides. Now 1 by EC is equal to 1 by FC. Now here numerators are again same and denominators are also, C is the common and E and F are the different, which is possible, that is, this implies numerators are same, means we can write as EC is equal to FC. That is, from the diagram, EC and FC will be equal? Never. That is, which is possible only when E and F are coincide each other. Coincide each other. Therefore, what is our imagination? Let us assume that DE is not parallel to BC. Therefore, we conclude that DE is parallel to BC. Hence proved. Let us see the next theorem. Vertical angle bisector theorem. Vertical angle bisector theorem. That is, the vertical angle of a triangle, the bisector of the vertical angle, the bisector of the vertical angle of a triangle, the bisector of the vertical angle of a triangle divides the base in the ratio of other two sides. This is the statement of the theorem. The bisector of the vertical angle of a triangle divides the base in the ratio of other two sides. Now, let us see the diagram. A, B, C. Now, bisector of the vertical angle, angle A is bisected and AD is the bisector of angle A. Now, given in triangle ABC, AD is the bisector of angle A. AD is the bisector of angle A. RTP, the vertical angle, the bisector of the vertical angle divides the base in the ratio of other two sides. That is, to prove AB by AC is equal to BD by DC. AB by AC is equal to BD by DC. We have to prove this one. Construction. In some questions, the given information is not sufficient to prove the theorem. In such cases, we have to add some additional angles and sides. Such parts are included in the construction. Now, let us see now produce, this is the construction part. In this construction part, AB is produced up to E such that C touches the E. Construction, draw CE parallel to BA, CE parallel to DA such that CE draw CE parallel to AD or DA such that BA produced to meet at E, to meet CE at E. This is the construction. Now here, this is the 1, this is the 2. Here angle 3, here angle 4. Now proof. Since AD is the bisector, AD is the bisector of angle A, then we conclude that angle 1 is equal to angle 2. These two are equal. Next, AD is parallel to CE, AD is parallel to, see these two are parallel, and AC is the transversal. AC is the transversal. Then angle 2 is equal to angle 3. Angle 2 is equal to angle 3. Reason: alternate interior angles. Similarly, angle 1 is equal to angle 4. Angle 1 and angle 4 are equal since these two are corresponding angles. Now angle 1 is equal to angle 2, this is equation 1. Angle 2 is equal to angle 3, this is equation 2, this is equation 3. Now from 1, 2 and 3, from 1, 2 and 3, 2 equal, that is angle 1 is equal to angle 3, angle 1 is equal to angle 3. But angle 1 is equal to angle 4, that is in place of that is angle 4 is equal to angle 3, since angle 1 is equal to angle 4. Angle 1 and 4 are equal. Now angle 1 is replaced with angle 4. Now angle 3 and angle 4 are equal, that is the side opposite to angle 3 is AE is equal to AE, and the side opposite to angle 4 is AC. AE is equal to AC. Therefore here we conclude that from triangle ACE, from triangle ACE, take that ACE out, ACE, AE equal to AC, AE and AC is equal. A triangle in which any two sides are equal, then it is called as an isosceles triangle. In isosceles triangle, the angles opposite to equal sides are also equal. That is, here I got that AE is equal to AC. Therefore triangle ACE is an isosceles triangle. Therefore triangle ACE is an isosceles triangle. Now let us consider another part, that is from triangle BEC, from triangle BEC, let us consider BEC. AD is parallel to CE. AD is parallel to CE. That is AD is parallel. AD is parallel. AD is parallel. That is DE. Replace D here and E here. Sorry, this is A. Now from BPT, from basic proportionality theorem, BA by AE is equal to BD by DC, which can be written as AB by AE is equal to BD by DC. Now since AD by AE nothing but AC is equal to BD by DC, hence the theorem. What we have to prove? AB by AC, AB by AC, this can be written as AB by AC is equal to BD by DC, hence proved. Let us see the next theorem. Ratio of areas of two similar triangles. Statement: the ratio of areas of two similar triangles the ratio of areas of two similar triangles is equal to ratio of squares of corresponding sides. Ratio of areas of two similar triangles is equal to ratio of squares of corresponding sides. Now given triangle ABC, triangle PQR are two similar triangles. Triangle ABC, triangle PQR are two similar triangles. Let us consider triangle ABC, triangle PQR. are two similar triangles. RTP, what we have to prove? To prove area of triangle ABC by area of triangle PQR is equal to ratio of squares of corresponding sides, that is AB square by AB corresponding side is PQ square is equal to BC square by BC corresponding QR square, and AC square, AC corresponding side is PR square. This is what we have to prove. Now construction. Draw AD perpendicular to BC and PS, PS perpendicular to QR. Now proof. Triangle ABC is similar to triangle PQR. Two triangles are said to be similar. The condition number 1, their corresponding angles are equal. Condition number 2, their corresponding sides are proportional. That is AB by PQ is equal to BC by QR equal to AC by PR, and angle A equal to angle P, angle B equal to angle Q, angle C equal to angle R. According to the similarity conditions, corresponding sides are proportional and corresponding angles are equal. Now consider area of triangle ABC is equal to half into, from triangle ABC, base is the BC into height is the AD, equation 1. Now again area of triangle PQR equal to half into, base is the QR into height is the PS. This is equation 2. Now equation 1 divided by equation 2. Area of triangle ABC by area of triangle PQR is equal to half into BC into AD by half into QR into PS. That is half get cancel. Therefore, area of triangle ABC by area of triangle PQR equal to BC into AD by QR into PS, which is equation 1. Now, from triangle ABD, from triangle PQS. Let us take these two triangles out. Let us consider these two triangles. Angle B is equal to angle Q. Angle B is equal to angle Q. Corresponding angles. And angle ADB is equal to angle PSQ is equal to 90 degrees each. Therefore, triangle ABD is corresponding similar to triangle PQS. Reason, angle similarity. Angle similarity. That is, from this we can write that these two are similar. AB by PQ is equal to AD by PS. This is equation 2. Since triangle ABD, triangle PQS, or else simply you can write from BPT, from basic proportionality theorem. Now, substitute equation 2 in equation 1. That is, area of triangle ABC by area of triangle PQR is equal to BC by QR into AD by PS.